Okay, so before you realize that you don't want to spend an hour watching this video, let me just tell you that you might actually need the 5 first minutes. So we're gonna go and do an overview of what multiplayer is and how it works, and then we'll go inside of the engine and actually apply it. We will be hosting directly on our machine, but it's a simple standalone application, so if you want to port it over to a Linux somewhere or any other computer really, you just open the IP and you connect through there. That is super easy to do with Unity. And also for the clients, we'll be using web browser. So we're going to be connecting through Chrome, we're going to be connecting through really anything. We can also use a standalone app if you want, but I wanted to do web browsers so we can actually do web sockets as well. That might actually be something that interests you. For me, I'd like to create some kind of multiplayer game on the web so people can simply connect, and it's way easier to test that way because I can just open multiple tabs on my browser instead of opening multiple applications. Okay, so if at any time during the video you feel like you've made a click, you feel like you actually understood how the protocol works, I really encourage you to go and try it out, as it is going to lock in the information in your brain and you'll be one step closer to creating that multiplayer game you want. Alright guys, let's get started. Unity's multiplayer, or UNET if you prefer, is actually done using socket. And when you have the socket, you create open connection in between the client and the game. This connection has to be maintained, so you can't actually just try and cut it, or you cannot have just a power outage and stay connected. You really have to stay connected in between the client and the game at all time. Now, of course, you can get disconnected for a while and then try to connect back. You can have an application that does that, but really the main goal is to maintain that connection and have a constant flow of data transferred in between the client and also the server. With this type of multiplayer, you can create synchronized games such as a racing game, a MMO, a MOBA, really any kind of game where you can see player move basically and have instant action on them. On the other end, if you want to create something more async such as Pokemon Go, you would go with a web server option instead. So it's simply you send requests when you need them, and in Pokemon Go it's something like every 10 seconds the player asks, okay, so is there something around me? And then the server gives him back a response, yes, there is this Pokemon here, this Pokemon there. So in these type of game, they talk to each other when they need to, and every time they create a new request, and then they have a response. We're not going to go through that. Actually, if you want to go through that, we have a Pokemon Go class coming up sometime this year. You just have to follow the channel, follow the Facebook page, I'll post about it there. But this is not the type of game we're going to be making today. We're going to be creating a synchronized game. When using UNET, you will quickly realize that it has been built in such a way that allows you to do peer-to-peer, which means that everybody that runs your game could potentially become a server as well, so they can receive data from other and they can send back as their own. But don't worry, if you need a client-server architecture, you can also do that, but having the perk to transform your client into a server later on is always a cool thing. Alright, so if you have a look at Unity's documentation under multiplayer, you will find out that you've got two different approaches. You've got a high-level approach that uses component in Unity, so component that Unity has to offer, or you can take a low-level approach, which is more complex but also gives you way more flexibility. It doesn't restrain you to do, it doesn't restrain you the same way as the high-level one does. And if your goal is to learn actually how to make a multiplayer game, I would really suggest taking a low-level approach, as it is going to be useful outside of Unity as well, while the high-level one is only going to work in Unity basically because you're using Unity's component. You'll also understand better the restriction you have when you make a multiplayer game if you take the low-level approach. And if that didn't convince you, I'm really sorry to announce to you that today we're going to be using the low-level API, or it's also called the Net Transfer API for Unity. And we'll create everything from scratch. It's gonna be like the multiplayer checkers tutorial. It's really the same. We're using socket and we're just sending data back and forth. But however, and if that didn't convince you, I'm really sorry to announce to you that we're not gonna be using the high-level API. We're gonna be using the low-level one. Because why would you be using the high-level one? You can't use it anywhere else than Unity. And you're here to learn, right? You're on the channel to learn. But don't worry though, it's not really that complicated. Alright, for the low-level API, the first thing you'll need to do, and that's for both client and server, is to initiate the transport layer. You will define how many people can connect to you, and also what type of communication channel you'll be using. Channels are basically ways to deliver your messages. There are reliable channel, unreliable, fragmented, and if you're not familiar with this, just ask yourself, does the receiver really needs that information? For example, if your client does a transaction involving in-game currency or like real money, you'll want to send that message on a reliable channel, so you're making sure that the message actually gets sent and gets received. It's a message that you cannot afford to lose, else he might get charged twice or other weird behavior if the message is lost along the way, so you really need this to be on a reliable channel. An unreliable example would be for the player's position. If the connection has some hiccups, you can afford to lose some position update from time to time, because there's always going to be position update every single frame when your connection is back to a more stable state basically, so those are always going to be overridden. We'll talk more about the channel when we create the example. So you've defined which channel you want to be using, how many people can connect to you. The next step is going to be to create a host, and that is something that might sound weird, but you have to do on both the client and the server itself, so you got to be creating hosts on both sides. Always keep in mind that the client can be turned into a server later on. Once you have that network layer, this is where you'll be taking two different paths based on if you're the client or if you're the host. The client will connect using a simple line of code, while the server will just wait for a connection and wait for messages. No additional line required. But in our case, we're going to add one more line to that server. We're actually going to open another socket to include the web sockets. And that's it. At that point, you have your client and you have your server. They're both hosts, but one of them, the client, is connecting to the server, so at that point they're connected that way. What you're going to be needing to do next, what's the next step, is you're going to have to check every single frame on both hands. You have to check on both hands, is there any messages? So did this client send me a message, or did this server send me a message? So you have to check every single frame on both sides if you have any messages. This can be done in a simple update function on both client and also server. There is only 4 types of messages you can receive on both ends. The first type is nothing, which means there is no message right now, so let's not bother doing anything else. The second one is connected, so somebody just connected to me. Third one is data. This is where everything's going to happen. We'll go more in depth really soon. And fourth one is disconnect. So basically somebody's disconnecting to me and now I have to remove him off my list of players or stuff like that basically. Now the really important one is just data really. Of course you're going to be connecting people and disconnecting them as they come and go in your game. But where your logic is going to happen, where you're actually going to have your gameplay and the whole multiplayer logic is going to happen in data. So let's say that player 1 wants to do a spinning attack or something like that. He's going to have to tell that to the server, and then the server is going to have access to everybody else. So the server has a list of connected player. What he's going to do once he receives that message from player 1, he's going to redistribute it to everybody else. So he's going to say, okay, everybody, player 1 is doing a spinning attack. And then just like that, everybody else can be in sync and have this spinning attack on their hand. Now, of course, if this is not clear to you, I just really encourage you to stay around. We're going to create an example like that in the future game that we're about to make. But yeah, that's really it for the big picture explanation. We're going to jump into the actual engine and start creating a server, a client, just have them communicating. I'll show you what kind of code I use, what kind of approach I have towards this, and we can start having these two things communicate. So guys, let's get right into it. Alright guys, so we've got a fresh project right here I'm about to create, and we're going to just jump into the multiplayer system and try to establish something that is quite simple. I don't have any games in mind. I simply want to have the player tell its name and then connect into a world where other people are there, and they can just move and we update the movement position just to tell everybody that there's other people around you and they can also move. So basic multiplayer stuff. And we are going to get started right away. I'm going to try and do my best to not get interrupted too much. I do have a code here to look at, so before I made this video I actually have like some kind of reference, and I'll try to go over it as quickly and as clearly as I can. So whenever you create a new project, you always set up the folders. Let's start with a script folder, a scene folder, and also I'd like to do a prefab folder in this case, since we'll be holding a player prefab. Alright, so the next thing I will be doing, let's actually start by making the client scene. I like to just quickly make a client scene, and then it's going to take like about 2 minutes. Then we'll jump into making the server, because that's really what we're here for. But we need to actually have something first. So I'm going to save this scene as client, put it inside of the scene folder. I'll right click, create a new empty game object. That's going to be, say, the client object, and on top of it I'll add a client script. Now that's pretty much all the setup we need for this. We also need a player prefab, which I will put in here really shortly. But before that, let's hit Control and N, server, and do the exact same thing, but for a server scene this time. So create an empty game object. That's going to be the server object. On top of the server object, there is going to be the server component, and we are going to open up these scripts inside of Visual Studio. So we're going to start, actually I said we're going to start with the client. That's a bit lie. Let's actually start with the server, because that makes more sense. You need to have something you connect to as a client. So the server is the first thing you need to start tackling. And so what's going to happen here is I'm going to open both server and also client, and we'll do the there's like a part at the beginning when we instantiate the network transport layer that it's basically the same exact thing. So we'll just copy on both sides. So on the server here, we'll start by declaring a few fields at the top. Let's start with a private const int max connection. That's of course how many connection can be connected to your hosting, so your computer, and that goes for both client and server. And just after that, I'll be using a port, so private int port. Oh, by the way, whenever I have a constant like this, I always put it in all caps, because that's how I declare my constant. So we have a port. We do not need the ID, because, well, we don't need the IP address, because the server is itself, basically. You're not connecting to anybody else but yourself. So in this case, server doesn't need that. We need a private int host ID, which we'll use later on. Private int web host ID, which is really interesting. Actually, it is for WebSocket server. And then private int reliable channel, private int unreliable channel, and I'll get in more details as soon as we reach this point in the code. And then a private bool is started to know if we are started. Finally, private byte error. So these are the fields I actually need for both the server and also the client. So I'll take these and I'll copy them over on the client as well. Now we are going to start by instantiating initializing the network transport layer, and this will be done in a start. So as soon as the server is started, as soon as the server scene is ran, we want to do network transport. So network transport, and to actually use that, we'll have to do using Unity engine.networking. So make sure you include this at the very top. Network transport.init, and that's pretty much the only thing we need to do to initiate this. And then we need to get into configuring that transport layer. So connection config, I'll call CC, is equal to a new connection config. And then at this point, we are going to start declaring what type of channels we're going to be using for communication. And this part is a little bit hard to understand when you just start with multiplayer, but basically when you have a connection between a server and a client, you can define, well, in this case, in the UNET case, you can define which type of message, how you're going to be sending that message. So right now we have two channels at the top. We have the reliable channel and the unreliable channel, and I probably pronounced that really bad. Don't worry about this. Reliable basically means that your message is going to be sent and it's going to be received 100%. So you're making sure that it is sent and it's being received in the same order as it's being sent and received, basically. If it's unreliable, it's going to be sent, but it might get lost along the way. So you need to actually make sure that if you're doing something important, such as a transaction or a connection, that your message has to be sent and received. If you're updating the position of your player, that does not have to be received. It has to be sent, of course, but it doesn't really have to be received, because on next frame it's going to be sent again. So if you have some kind of hiccups during the communication in between the client and the server, it's not that big of a deal if you lose some position update, because they keep being overridden every single frame or every single update loop. So that doesn't have to be reliable. That is a lot less costly. So on the server side, it's not going to be that expensive to actually send that message. And if it is actually being received, then well, that's a good thing. And if we have a hiccup, it's not being received. We're going to see like a small lag spike in the game, and eventually it's going to go back to normal. So to add these channel in the UNET, it's really easy. Let's actually use our reliable channel in and say it's equal to cc add channel, and then you have the option. So we want to be adding a reliable channel in our case for important information, and unreliable channel for movement updates. So add channel unreliable. There's also other channels such as reliable fragmented, so that's for big chunks of data when you have to send more than just one, and also unreliable fragmented, and you can just look up the rest. Once we have our channels, we need to declare a host topology is equal, actually let's name it topo, then it's equal to a new one, and it takes in a CC, so a connection config, and also the amount of connection you're going to take in, so in our case max connection. And that's actually all we print. Actually no, we need more than that. We need a host ID as well, and we need to add the host. If you guys remember when I actually did the intro, I said that both the client and the server can be hosts, which is true. So this is what we do here: network transport, add a host, and in case of the server, we start by adding the topology, and then the port is going to be the port we define at the top, and finally the IP at the end is who is actually allowed to connect to this guy. So since we're a server, we're pretty much accepting connection from anybody. We are going to say null. By saying null, it's just going to accept connection from everybody. Now something interesting we're also going to do here is we're going to add a web host as well. So we're going to do network transport add host, add WebSocket host actually, with the same exact settings. And that is actually really cool because you're going to be allowed to run your server, say on your Linux machine or on your Windows machine, and connect to it using WebSockets. So other people, when they play, they can actually they can fire up browsers and actually connect to you. So that is something very, very cool. Once we're done with all this, we're going to say is started is equal to true. And at that point, we can start running the update loop in a little moment. But before that, let's copy all of this and move it over to the client. However, we're not going to do that in the start here. I'd like to do that on demand. So as soon as I click on the connect button when I play the game, so public void connect. I'll just make sure I have a public function that I can call from a button basically. And then I'll paste everything in here, and we're quickly going to have a look at this. So first, let's include the Unity Engine networking, and then we're going to be having a look down here. So that's fine. Connection config, they have to be the same. So on both the client and the server, you need to have the same type of channels. So we have both reliable and unreliable, so that's pretty good. Topology is also good. And now in terms of the WebSocket host, this does not actually exist. So you cannot start a server in a browser. You really have to use a Linux standalone build or a Windows standalone build. And now in terms of the web host, this actually goes away, unfortunately. You cannot start a server in a browser. You really have to actually use a standalone Linux or Windows build or Mac OS, whatever you want really, but really you can't do that in a browser. You can only use the client in a browser, not the server. So that being done, we are going to swap just the wording of this a little bit. Instead of is started, we're going to say is connected. That's going to be useful later on for us. And actually we're not connected at that point. To do a is connected, we need to actually connect to the host, and to do that we'll do connection ID. So connection ID, do we have a connection ID? Did I had one earlier? I did not. So at the very top here, private int connection ID. It's going to be useful for us in the future as well. And then we actually do the connection. So if you guys remember in the intro, I said server code and client code is the same thing, but at the end, if you're doing the client, you have to actually use the connect function. So network transport, if I can type, then we do connect, and we're connecting to host ID. The address is where your server is. So in this case, since I'm on localhost 127.0.0.1, It's the same exact thing for you. If you're on localhost, you can actually type in localhost if you want to. I'll be using the actual address and then the port you're connecting to, so it's the one we have up top here, 5701. Sounds like a good port. Could be really any number that is not taken. And then what is this parameter? Int exception connection ID. Put a 0 in here and then out the error. And just like this, we have connected. So is connected is now equal to true. I'll do something else though, just to actually have some kind of game flow wrap around this. Is I'll also add another boolean up here. Private bool is started. I'll put that on false, and I'll also do private float connection time. So when exactly did we get connected? So connection time is equal to time.time down here, and that's going to be used for some kind of timeout mechanic. So in case you're the client and you're trying to connect to the server, but the server isn't there, you want to let your client know that he's not able to play on your server right now. Okay, so that is it for the connection. At this point, they're both connected. They can actually communicate, but none of them is actually listening. So they can they can talk, but nobody's listening, which is a big problem in modern day. Private void update. We're gonna start listening, and that's in both server and client. And now I'm going to be a bit lazy and actually copy over the code they have on the transport layer API. Let's go down to the update and just copy all of this. So I'm going to copy this, put it in the update loop, and that's for both the server and also the client, because both have to listen basically. So we'll do the same exact thing here, private void update, and we copy this code over. However, we do not want the update to be ran if, in this case, if it's not started. So if actually, in this case, it's not connected. So if it's not connected, let's return for now. Same thing on this update loop. So if is not started, so is started with the negation sign in front of it, we simply return. Now let's have a look down here, because this is a really interesting function. If you just have a look here, we have the receive function, which is pretty much where everything happens basically. So as soon as you send a message, you're going to use network transport.receive to actually get it, and it comes in with a lot of information. So you're going to know who exactly sent this. If you're the client, only one person can talk to you in our case, and it's the server. If you're the server, you can get the connection ID of who exactly, which client is talking to you, and every single client is going to have a different connection ID. Then the channel ID, so you know if you're on the reliable or unreliable channel. The rec buffer is pretty much just is the receive buffer, and it's a byte array with your message, with your data basically. The buffer size is going to tell you how big is that byte array, so where you have to stop reading. And what else? Actually, the buffer size is going to be like 1024. That's for the big size of the buffer. If you go beyond that, your message has to be fragmented. The data size is going to be about how big the buffer is. And what else? And that's pretty much it. This receive function is, however, going to send you a network type event. So when you receive a message, you're going to know what type of message it is. If you're receiving a message of type nothing, it basically means that there is no message, and it's just to fill in your update properly. If it's a connection event, then it means somebody's connected to you. Simple as that. Disconnected is the same, but somebody has disconnected from you. And data event is where everything happens basically. So this is where you have to parse your messages to know what it's saying, and then you can actually take action from there. A real example is going to be coming up really soon. We're going to start working on we could start working on actually trying to sign in. So let's go ahead, and in our client I am going to create a new canvas, and that's going to be super quick, guys. So a new canvas, I'm also going to be creating, say, a image as a background. Call this background. Make it as wide as I can, and on top of this I'll be using a new UI input field, name input, and below that name I'll be using another button for the connection. So that's going to be the connect button. I'll move it down a little bit right here. It doesn't have to be pretty, we're just making this so it works. And we have the connection right here. Alright, Now if we head over to the connect button, on the onClick event, I'll be clicking on the plus sign, adding my client to it, and just linking my connect function that we've made. So whenever we click on connect, we are going to be calling this function right here. Alright. Right before we actually try connecting, I like to make sure the player has a name. That's just like a small constraint. So before we actually get to the cold connection flow, does the player have a name? And we'll go fetch the name inputs game object dot find name input. I think I called it name input. Just make sure. So yeah, name input is the name of my input field. I'll just be finding it via its name, and then we'll do a get component type of input field, and that's going to be in the Unity engine.ui, so make sure you include that at the very top here, and we can get the .text. I'll actually store that into a temporary field, so string pname for player name, and that's going to be our name. So if pname is equal to nothing, then we need to enter a name. So debug.log, you must enter a name, and let's also hit return. And then if he does have a name, let's store it somewhere. So we'll have a private field up here, so private string player name. That's going to be our very own name, so the client's name basically. Player name is equal to pname. We'll be using it later on because the server doesn't really know you until you tell him who you are. At first we have the connection, so the client is going to try and connect to the server, and then the server is going to say, oh, that's a new connection right there. He's going to ask the client for its name, and then the client is going to send the name back to the server. So it's like multiple transactions just to give the player a name, because you can't actually send your name with a connection. It's one different thing. Basically you have to do it in 2 steps, which is fine because we're going to be taking care of that really shortly. So yeah, at this point we click on connect. If we have a name, it's going to try and connect. So that's fairly cool. Now what else? What is the next step? We can start actually parsing our data. So at this point we're connecting. The server on this side is going to receive a connection event. And before we actually go any further, I'd like to actually test this out. So debug.log, let's say player and then plus connection ID, because that's the unique ID for everybody, has connected. We'll also copy this over for this disconnection event. So player connection ID has disconnected. We can also do data, so instead of saying player has done something, we're going to say, well actually player connection ID has said, or has sent is a little bit better, and then we'll send the actual message. But for this message to actually go through, we need to parse it first, because right now it's in a byte array. So quickly we're quickly going to get into encoding this message first. You guys will understand what I'm doing in a second once we actually do it the other way around as well. So string message is going to equal encoding. Encoding is inside of system.text, so make sure you include system.text. I'll be using Unicode because I plan on using special characters for the messages, so Unicode is good for me. Get string with the rec buffer 0 and the data size. Okay. Let's actually try this out really quickly. We're not going to get any data event because we're not sending anything just yet. I'm just putting this code here for later uses. So what I'm going to do right here is, since our debug.log, the thing I actually want to test out are on the server.cs, is I'm going to actually run the server inside of the editor, and I'll be running client from outside. So what I'll do is quickly go inside of file, build settings. I'll add my client here, do a build and run, and I'll just actually, let me go in here and say this is my build, and I'll be running a client really shortly. Now realize that I'm actually running this on a Windows PC. We could also be running this in WebGL if we wanted to. and I'll show that example at the end. Let's go with something really small. And now we have our client right here. It's not connected because we have to click on the button before. So before we actually do anything else, we are going to go inside of the engine, press on server, and now it's running the server, basically. Or it should be running the server. Okay, so here it is. There's no graphics, nothing is going on. We don't really know what's going on, basically, but this is a running server. Now if we go in here and actually type in hello or something, whatever, so we can connect, do we get any messages? We don't seem to get any messages thus far, so we're gonna have to do a little bit of bug fixing. Oh, actually we did get some message. Player 1 has connected, and also player 2 has connected because we did 2 connections. That's something we have to fix as well. However, we did not get the message in time, and that's because the background it's not running in background. So the application, we have to go under player settings, run in background. And that is a really bad mistake because, like I said, since we have open socket, we have to maintain the connection. However, when Unity does not have the editor in focus, it's not running the application, so basically the server is not responding anymore. We have to make sure that both application, both the client and the server are running in background so we can maintain that connection even though we're not focusing the application. So let's try this once again. Go under server. The server is in the back right here, it's running. Now we're going to say hello. Connect. Player 1 has connected. And if we actually just shut it down, player 1 has disconnected. So we lost connection with the player 1 and it has automatically disconnected. That's pretty cool. So we have our very first step here. The hello doesn't do anything. I mean, we're not sending any messages with our name in it. However, we are calling the connect event inside of the server. So that is fairly cool. We can actually go from there. So as soon as you connect, let's call on connection. That's going to take connection ID. On connection is a new function, so private void on connection, that takes in an int CNN ID for connection ID. And now once we connect, we know exactly what's the ID. So we had player 1. If we did double click on the button, we had player 2 as well. So we had 2 players, and like I said, that's a bug right now, but at least we have different ID for everybody. So that's the whole point of it. When somebody connects, we need to tell him exactly what ID he's gonna have on the server because he doesn't know that just yet. He's only connecting, and we need to tell him, okay, so you're gonna be player number 3. So he needs to know that information, and then we need to add him to some kind of list so we can keep track of him later on. So we're gonna start by adding him. So add him to a list. Then when the player joins the server, tell him his ID. Also request his name, and that's pretty much it actually. Request his name and send the name of all the other players. Something also really useful. So if you join in, if you're the 3rd player to join in, you're gonna receive your ID. It's gonna say 3, but you don't know who the other players are, and that's annoying. So you need to know the other player, who they are, so you can actually spawn them when you actually spawn your player, basically. Alright, so we're gonna add him to a list. To add him to a list, we need to start actually keeping track of those players. So I'll be declaring a simple structure at the top here, or a class, why not? So private class server client, and server client is gonna be the definition for client, but only for the server. That's not being sent ever to the client, or it's not being used in the client. Public int connection ID. In public string, they also have a name, so player name. And that's really all we need for them at the moment. So when somebody connects, we need to declare a server client for him. So server client C is equal to a new server client. C dot connection ID is equal to CNN ID, the one we received, and C dot player name. Let's put that on temporary for now because we still don't know what the name of the player is. Right now he has connected. We're sending him a message back, so we're sending a message asking the name and also telling him his ID at the same time. but we still don't know his name because he has not sent it yet. We need to send him this onConnection message first, and then he's gonna reply to us with another message. So give him a temporary name, we'll call it temp, then client.add. We don't have a clients list. Okay, let's actually go add a client list. So at the top here, private list of server client. That we'll call clients with an S, and it's a new list of server clients. So we'll be using this to actually keep track of every single client connected to us. Sorry about the zoom in and out. I'm just figuring out I have a control key. So clients.add, and we're adding C. So at this point we have the definition for this guy. We only know his ID. We'll know his name later on. And to actually know his name, we need to start, well, first sending him a message. And in the actual message we want to send, we said that we also wanted to send the connection ID. Okay, so that's a little bit complicated. Let me quickly just try to clear it up by writing it down. String message, we're going to say ask name, and then send the CNN ID. Notice that I'm actually formatting this in such a way that I can split the information with a string.split. We'll see that in a moment as well. So that's my message right here, and then I want to send the name of all the other players, so I'll do a for each on the player array. So for each server client SC in this case, in clients I'll do message is plus equal to the player name, so that's going to be sc.playerName, and then we'll add another special character in here plus sc.connection ID, and I'll add another pipe. Once we're done filling all that information in, I'm going to remove the last pipe at the end by doing a message is equal to message.trim. We're going to trim this pipe sign. And then finally, once we have our message, which is basically going to be composed of, let's assume that there is two connected player right now. Our message is going to look like this. So ask name, then say you're the third one. So if there's already two player connected, you're the third one. It's going to say 3 here, and then it's going to say the name. So first player is called Dave, and he is connection ID 1. And then the second player is called Dave 1, or actually, let's call him Michael. Why not? His ID is 2. So it's gonna look something like this. And since we put that at the very top here, we're also in it our own name. In this case, that's gonna be temporary and then ID 3. But basically, that's the information we're gonna get on the other end. Now, once we're on the other end, we're gonna say, okay, so these two information, they're useful for us. And then once we hit the second pipe, we have Dave and his ID, we can add him in. And then we have Michael and his ID, we can add him in. And then we have temp, and the ID is number 3. That's our ID, so that's us right here. This way we're going to be able to know what's going on the other side by parsing this message in such a way that's going to be useful for us later on. Okay, so we have the message, we need to send it over. Now, how exactly do we send information to the server or to the client? Actually, on both sides, it's the exact same thing. We have to use a function called send, which is in the network transport. So network transport dot send, and this one takes in a host ID, connection ID, channel ID, a byte buffer for your data, the size of your byte buffer, and also a byte for error if you have one. However, we're going to be using this quite a lot, and it's a lot of information. We have to parse our message, turn it into a byte array every time. So I'll be creating some helper function down here. Private void send. I want to be sending a message, so that's my message. Which channel am I sending on? So channel ID, and also the connection ID, so CNN ID. Where exactly am I sending this? So who am I sending this to? If you're the server and you only want to send a message to a specific user, you have to do you have to input is specific connection ID. So what do we do in here? We're going to say something like byte array message is equal to encoding Unicode, like I said, and then get bytes, and we turn our string into a byte simply like this. Once we have our message like this in the byte array, we can actually send it over using the network transport.send function. Now what I'd like to actually do right here is actually we have all we need, but I'm going to create an overload. So of the same exact function, call it send string message int channel ID, but right here I'll be using a list of server client. The reason I'm doing this is it's actually the same exact thing as I've done in the multiplayer checkers, is so I can actually decide if I'm sending this to only one person or sending it to everybody. It's just gonna help me out with those messages. So I'll actually be using this byte array down here, and up top I'll declare a list of server client C is equal to a new list, and I'll do c.add find the client I'm actually looking for, clients.find x connection ID is equal to CNN ID. So I'm creating a list that only contains this one specific user I'm targeting, and then I'll be using my overload down there to actually do the send message. So if we're calling this function, it's actually going to create a list and then call this one instead. Alright, and since we like to have some debug information, we can also do debug.log and sending, and then put our message in here before it actually becomes a byte array, else we're not going to be able to read it instead of a simple string like that. And then for every single server client, sc in clients, or actually in C, because that's the one we receive in parameter, for every single client that we define, we're going to send that message using network transport send host ID, and then that's the connection ID. So who are you sending this to? At this point, since we're in a for loop, we'll do sc.connection ID. If we're sending this to every client, it's going to iterate through every single one of them, and every single one of them has a unique one. The channel ID is the one we receive in parameters, so are we sending this through a reliable or unreliable channel? As far as the buffer goes, we have the byte array which is declared, and then the size of that buffer will do message dot length, and that's the string, that's not the byte array, that's really just a string, and we'll do times size of a single char, because a string is made out of chars basically. So for every single letter we have in that string, we'll do what is the size of a single character, and then we'll just multiply that. We'll have the proper size. We can also do out error at the end. Okay, so we should have pretty much everything we need for this guy. We're gonna come back right here and just do our send message. Send using our own function. The message is MSG. The channel is the reliable one. We want to actually have this connection or this message sent and received properly. And the connection ID is, we're only sending this to one person, and that's the person we receive on the onConnection event. So that's a big chunk of code just for connecting, and it's not done yet. We still have to do the asking for a name, and we also have to do the code for the client side of things. Okay, so we've got a message sent over. Let's go over to the client side and start receiving it. So if we head over to the update function on the client side, there is really not any time where we're going to receive a connection event, simply because nobody's connecting to us in this very specific case. And also, this connection is the same exact thing, so I'll remove both of these, and the nothing one is really not useful for us at all. So we're going to remove everything but leave the data event. In which case, I also want to go back in the server and delete the nothing. We're not going to be using it. It's going to make our code a little bit clearer. And here we go. So we are right here. Now, before anything else happens, is I'm actually going to not decrypt, but decode my message. Right now it's encoded as a byte array. So what I'll do in the client is say string msg for message is equal to encoding, and we have to use system.text at the top. So system.text Unicode and then we'll do a get string right here. It's going to be the same exact thing, so we're getting the receive buffer starting at index 0, and then the count is going to be data size for how many bytes we need. And that's going to give us our message. Then we can go ahead and just put it in the log, because why not? We like having those messages. Receiving plus message. If you guys remember, the message we're sending is this one right here. So this message, that's what we're going to get if there is a total of 2 players connected before we connect. If there is only one and it's us, then it's going to look like this instead. Or yeah, like this instead. But we get the whole point. So we get a message that says ask name and then your ID, and then the rest is just other players that are connected to the server. So let's actually parse that in a certain way by saying switch. At the beginning, we're going to be switching. Actually, no, sorry. We're not going to be switching just yet. We're going to be splitting our messages based on the pipes, because it's really all about the pipes here. And what type of function we're going to be calling on the client side is always going to be depending on the first thing we get here. So if the message, the first message we get is ask name, then we're going to redirect this to a function that takes care of that very specific operation. If it's position update, then we're going to redirect to another position in the code. So I'll be creating a we're going to be creating a name request function. Let's call it name request. So down here, private void, or you know what? Let's do on ask name. So when we get the server to ask our name, we're going to be calling on ask name, which is going to be our function. So this is where we're going to be doing a switch statement. In this switch statement, we need to decide, okay, so what is the type of message? What is the type of operation you're trying to do? Are you trying to ask me my name? Are you trying to say that somebody else is connected? Are you trying to say that somebody else has DC? Are you asking me for position? We need to know what is the first part of that message. And to do that, we'll start by splitting our string apart. To split our string apart, we'll do string split data or something like that. We have to declare this as a string array. So split data is going to equal message dot split, and we split on the pipe sign, because that's what we use to actually do our messages. You can be using any other special character you want, as long as it's part of the Unicode. Then we're going to check, okay, so if split data at the index 0, if it's equal to ask name, then we do on ask name. Break this. If it's equal to CNN that we'll use for connection later on, then we'll do something else. If it's DC, then we'll do something else again. And in case we can't read the message, let's also type that in. So if default, then we'll say debug.log invalid message, and we'll just type it in again, just to make sure that in case we have not written our message properly on the other side, we have to fix it. So like this, we'll be able to know. Okay. Now there is something we have to do in here though, is since we're asking for the name, there is more information to that message. It's not only ask name and then you're supposed to send something. You're also, like I said, you're also receiving your ID and then the name of everybody else. So what's going to happen inside this function depends on the rest of the parameters. So what I'll do is I actually send in that split data array, string array data, and we'll be using it down here. So the first thing that needs to happen is we know that index 0, we know that this is ask name. We don't really need to do anything else at this point, since we're already got through this point. On the second index, we have the connection ID. So we need to actually tell, okay, so this is us, this is our ID. At the very top, I'll be declaring right about here a client ID, and that's going to be our client ID. We can call it our client ID. We can say our client ID is equal to data at the index 1, And that's not going to work simply because data.index1 is a string, so we have to parse it first. So int.parse data.index1. So set this client's ID, and then we have been asked to send our name. We can also send our name to the server, and then we can also create all the other players, because after those two first parameters we still have the rest of the other players sent in that same message. So create all the other players, and like I said, it's just a matter of creating your own logic about that. You can decide not to send the other players. If you're like creating some kind of lobby, you're just connecting to a master server and then you want to have a list of the lobby, you can actually send that instead. It's not always important to send a list of everybody else. If you're thinking about games like Diablo or any Blizzard game, they don't send the list of every connected player. They send you your friend list. Like they send you what you're interested in seeing, like other players that have played with you recently. They don't send you everybody else. But in our case, since we're having a game where everybody moves in the same world, we'll actually send every other player. So to create these, we can actually create a loop. So we'll do for int I is equal to 2, as long as I is smaller than data.length. Actually, let's do length minus 1 I plus plus. The reason I'm starting at 2 here is because index number 0 is ask name, index number 1 is your ID, and then 2 might or might not exist. If you're the first one, it's not going to exist. If you're the second player, it is going to exist, and from there you can actually just read that data by saying string array d is equal to data at index I dot split, and this time we're not splitting on the pipe, we're splitting on the modulo sign. With that data we can start spawning players. So let's do spawn player, again a function we do not have just yet. It's going to take in, let's say it's going to take in the name, so let's do d at index 0, that's the name, and d at index 1 is the ID. In this case that's an int.parse this string. Okay, private void spawn player takes in a string for the player name and a int for player ID, or CNN ID in this case, for connection ID. And there we go, so our function works now. Of course there's nothing inside of it, but it should be called for every single player that is on the server when you join. Now the only thing we need to do here is send our name back to the server. So he asked for the name, he sent us information about the game that is going on right now. Let's actually tell him that we do have a name, and we're pretty much ready to connect. Well, actually not connect, but start the game. So we need to send our name. At this point we do not have a send function over here, so we do the exact same thing as we done on the server. We'll copy this over. We're not going to copy the first one because actually we're going to copy this one here. The reason I do not want to be copying the same exact thing is because we're never going to need a list of client. We're only going to be needing actually nothing, just a message and a channel ID, because we only have one host. We're only like talking to one person as the client, and we don't really need to do anything else. So at this point I'll leave the sending message in here, that's cool. The byte array is something we need, and then we don't need to do this. All we need to do is the network transport dot send. Instead of sending through the connection ID here, we'll send, well, just connection ID, so not any specific client, then it's connection ID. The connection ID is already linked to the host in this case. And that's it. Okay, so we have the send function. We can go back on the onAskName and actually send our name. So what exactly do we have to do here? Sending the name is simple. We're gonna say something like name is, and then put a pipe sign plus player name, and we want to be sending this on the reliable channel. Okay, if you're following right now, you know that as soon as we connect, we're triggering this function on the onConnection function. And then at this point we fill in some information on the server side, that's cool, but then we send the ask name message. The ask name gets in here, run this, and then sends the name is message with the player name, the one in the input box. And then again, at this point, we have to go back here, and on the data event, we need to have actually a way to parse our message first, and then reply to the name is. Or you don't even have to reply, but in this case we will, but at least, you know, a way to tell the server what is the name of the player. So I'll be going back in client really quickly, take this chunk of code and put it below the data event for the server as well. So string messages is already done. We're receiving from connection ID and then the message itself. We still split our data. We still need to split because we're going to be working the same exact way as we work on the other side. And if our message is name is, then we're going to do something like on name is, or a function that just parse this thing down here. So I'll do private void on name is. So when we receive a name, basically. And let's actually add the connection ID in here. So int CNN ID, and also string player name, just like this. So we don't have these case right here, we only have the name is right now. I'll be putting it here. Now, how exactly do we parse our message? If we go back in the client, just have a look. We do name is, then the player name. So name is 0, and then player name is split data at 1. However, we're also taking in the connection ID. I'm going to be using the one we received directly in parameter. We don't need to send it over simply because the server knows who he is talking to. So that's the first parameter. We're going to say connection ID and then split data 1. Okay, so that's a lot of back and forth, but at that point we finally enter the onNameIs function and we can actually link it. So link the name to the connection ID. And then the next really important part, tell everybody that a new player has connected. And we did not do this on the moment he connected, we did this on the moment that we receive its name, so we can actually save one transaction right there. We can actually save, you know, if we did it as soon as he connected, his name would be temp. But now since we're doing it as soon as we receive its name, we can send the information to every other player by saying, okay, so this guy is connection ID number 3 and his name is Dave. So to link the connection ID to the name, we'll say client, and we'll find it again. So client.find, use the predicate for connection ID is equal to CNN ID dot player name is equal to player name, the one we receive, of course, in parameter. Now to tell everybody that we have a new player, we're gonna say send. The message is gonna be like CNN for connection, and then we'll send in the name. So let's do plus player name, and then split that with another pipe, and then we'll send the connection ID, so CNN ID in this case. We want to be sending this over to the reliable channel so we don't lose that information, and we want to be sending this to every single client. And this is why I created the overload earlier, because you can already send the list of client of everybody that is on the server basically. So alright, we have this working. Well, actually, I said we have this working, we haven't tested out in a while. Let's actually go do that really quickly. So I'll go on the file. I'll be running the actual client from a standalone and the server from the editor, so we can actually read the console. So here it is, that's the client right here. It's not connected just yet. I'm going to double click on server and create a new instance of this as well. So let me just boot another build. So we have 2 clients, why not? This one is going to be called Dave, and let's see what happens. So player 1 has connected. We send him ask name with his number, that's 1. His name is temporary for now, and then we receive my name is Dave. Then we're sending that back to everybody. So we're sending a message to everybody saying that new connection has arrived, it's Dave, and his connection ID is 1. And then with this guy, let's call him Michael. Connect. Same exact thing, however, when he connects, we send him a message that says, okay, so there is Dave, that is already on the server, and there is Temp, which is basically you, because you're matching this ID right here. Your name is Michael, that's cool, and then we send that to everybody, so everybody knows that Michael with ID number 2 has connected. So that's pretty cool, that's working. We are now at the part where on the client side we have to create Michael. So CNN is the message we receive. Let's go on the client side and actually start parsing this. So I already made a slot for this. When somebody connects, I simply want to spawn him, so spawn player. The player name is the first thing we receive, so we'll do split data. Well, it's the first thing we receive after the operation message, so CNN, and then we have the name, and then we have its ID, so int dot parse split data at index 2. And just like this, we should be calling the spawn player function. Now for the spawn player function, we are going to do, I want to be keeping track of every single player's game object and also their name and also their ID, so I'll be creating a definition at the top here, public class player, and player is going to have a public string player name, a public game object, that's going to be his avatar, and a public int ID, that's where his connection ID. Might as well just write it like this, why not? Okay, so when we spawn a player, I'm also going to be adding him to the list, since both function that spawns player are actually going through the connection process and the when somebody else connects process. Let's start by creating a game object, why not? So game object go is equal to, do we have a prefab? We don't have a prefab. Let's do instantiate player prefab, which we'll create in a moment, as a game object. Back at the top of my script, I'll be creating, or somewhere about here, public game object player prefab, so we can actually create one later on, put it in here, and it's gonna spawn a prefab every time somebody connects right now. Then check, is this ours? So if CNN ID is equal to this, the client ID, we don't have to use this, I'll just use client ID, our client ID. If it's ours, then we're going to do like a bunch of operation. We're going to add mobility to it. We're going to remove the canvas. We're going to, toggle is started to true. That is really important. For the canvas, we can actually do that right away by saying GameObject.find, find the canvas, set active to false, and okay, so that's all we need to do if it's ours. Now if it's not ours, we're gonna keep on creating that player by saying player p is equal to a new player, then p.avatar is the game object we spawned, p.playerName is the one we receive in parameters, so player name, the ID, so connection ID is the one we also receive in parameters, so connection ID like this. What else do we need? We need the that's pretty much it actually. Let's actually add it to an array right now, or sorry, a list. Just like we have a client list on this side, we're gonna have a player list on the client side. He also needs to know who is playing with him at the moment. So public list of client, or sorry, not client, players. So a list of players that we'll call players is equal to a new list, and then at the down there I'll say players.add, and we're adding p, our new player that we just created. Okay, so it feels like it is going to spawn our game object prefab, but we don't have one just yet. And then we need to add mobility to it, so we'll have to add a little bit of gameplay. I'd also like to add a name tag on top of it. That could be also very cool. So I'll be doing that as well. let's quickly head back inside of the client scene. I'm going to create a cube, nothing too complex. Like I said, we're trying to make this working, not pretty. We have a cube right here, that's going to be our player. I'll remove the box collider on it. I'll put a character controller and also put a, can I put a text mesh on it? I can't, okay. I'll create a children under this cube that I'll call player. I'll create a children, so create empty, and I'll put a text mesh on it. Let's see if we can actually put that on top of the player. I'll call this name tag, anchor upper center, why not? And center, tab size, okay, that's not it. I need to just make it a little bit smaller, so 0.3 sounds good with a different color. That could also be cool. And maybe just put it right about there. So when we move our player around, we can have a name on top of it. Okay, so that's our player prefab right here. I'm going to drag and drop this inside of the prefab folder, add it to the client because it's public. And here we go, so we have disconnected. Now I'm kind of lost in the flow of things. I need to add legs to this guy so he can actually move around. I think I'll do that last because that's just gameplay. Something I wanted to do really quickly though is add, well, not add, but change the name on that player tag. So I'll say p.avatar get component in children, in this case text mesh dot text is equal to player name. And I'm actually eager to try it out right away. I'm actually going to remove this guy. Make sure we apply first, then remove him. Let's boot a server. No, actually, let's boot a client again. Why not? So I'll be building a client and I'll be booting the server from the inspector, sorry, the editor. And we'll see what kind of result we're gonna get. So that's my server, empty, boring as always. Let's call this one Dave. And Dave is right here, just chilling. Now I'll boot another Dave, or another client. See if he has the proper name. And also see if he's being sent over to this guy, that's also very important. Connect, and he is. And also this one also has Dave. Now it's really hard to tell because they're stacked on top of each other. But this one knows that another player exists and that his name is Dave. He also created a new player prefab, so there's two players right now. They're just stacked on top of each other and we can't move. Let's super quickly just add legs to this player. I'll add a player motor. And we're gonna script that in like 2 seconds because we're so used to making these type of script that it is now almost automatic. Private character controller. And I do not have IntelliSense. Why? Let me go get IntelliSense really quickly. Sometimes it would just go out of sync. It's really annoying. Okay, so do I have it? I feel like, okay, I got it now. Private float, vertical velocity, then private void start, just to assign the controller. So controller is equal to get component, type of character controller, private void update. In the update we start by declaring the inputs, so inputs is equal to vector3.0 at first, and then we can only move on the let's only move on the x-axis. So input.x is equal to input get axis horizontal, so we work with both arrow key and the WASD. Then if the controller is on the floor, so if it's grounded, we're gonna say vertical velocity is reset to something like -1, so he just sticks on the ground. If we press on spacebar, however, so if we do get button jump, then vertical velocity is going to change a bit. It's going to be changing for the jump force. Let's do 10 in this case. Why not? Like I said, just quickly going through this, so all of these values might be very boring. And then quickly add gravity, minus equal 14.0 is always my go-to gravity. And finally inputs, the y is equal to vertical velocity. Whoops, my bad. yeah, it's equal to vertical velocity, and then we finally move. So controller dot move using the inputs times time dot delta time. Here we go. So we have our player motor script. We did it quite fast. Hopefully everything is good. Now what I'd like to do is go back in here actually, and in my client, when we say add mobility, all we really want to do when we add mobility is simply just add the component to it. So geo add component player motor. Now if my server is running, I feel like actually booting a server right now, so I'll just boot a server by adding the server to this list, make sure it's actually the first one in the list, and then that's going to be my server build, and I'll be running it in the standalone. Here it is. Then I'll open up the client. Oh, we also have to enable this, of course, because it's reading on ports. And here's my client, so Dave. And here is, so gravity is not doing him well, but as you can tell, he could move. Let me put some kind of floor, so a cube floor down there. Play that again. And it's Dave and the name test, and that is because we're never really disconnecting the other player, so we're having some bad glitches here. So what I feel like doing quickly again, just to test out our last feature, I'll be building my server again and I'll be running it, then see if we do have any problems when it's only one person on the server. So that's my server right here. We just built it. It's a fresh build. Dave is here, Dave is moving, he's able to jump, do all that kind of stuff. If we add another one, oops, my bad. If we add another client, can we actually add another client? We're gonna add another client using the previous build. So I'll just be using this guy here. It's not gonna work on this thing, it's gonna work good in the inspector though. It should work good in the inspector. This one's gonna be Michael, connect, and this one still have the glitches, that's fine, it's not moving, that's totally normal. But as you can tell, he's right here, he's not moving, and he's just doing its thing. Pretty good stuff. Okay, let's close our server, let's close pretty much everything. We need to do the disconnection part, because that is a big problem we currently have right now. We're not removing the player when they leave. So what we need to do on asking that's good, spawn player, let's do also despawn player, or should we do player disconnected? We're gonna do a player disconnected instead. So private void player. There's also one right here on player disconnected, but let's not use it because that's the high level API stuff and we don't want that. So I'll just be saying player disconnected, not the on player disconnected, because that is a callback and it's going to mess everything up. Once a player disconnects, we're gonna say destroy. We're going to destroy his CNN ID, his avatar, like this, and we're going to remove him from the list. So player.remove CNN ID, and I think that's really all we have to do. Could have done that a little bit earlier. Okay, so that sounds great. I am going to actually, you cannot convert this to a player. Why exactly? Oh, I'm actually using a list of player, am I? Yeah, I'm using a list. That's not a good thing. I don't want to be using a list. I want to be using a dictionary instead. So let's swap this player list for a dictionary. We want to have a int, that's going to be the connection ID, and then the player object next to it. So new dictionary int player, like this. Now we're gonna have a crash when it comes down to when we added it. So we added over here CNN ID for the key, so that's the connection ID we had earlier, and then the player structure. When we remove using CNN ID, which is the key in this case, and the value is of course the player. Okay, so we never get the DC message and we never actually act on the DC message. let's start here. Why not? All we have to do is say player disconnected, and we're gonna receive the we're gonna make sure we send the ID of the person who's disconnected through the messages on the server side. So int.parse data at index 1, or sorry, split data at index 1. So we're expecting that message from the client. However, the server is never going to send this at the moment. We need to make sure actually that he does that. Why do I have a double break here? I don't know. But when somebody disconnects, so right here, we need to make sure that we actually send that message. I'll do a private void on disconnection. Disconnection. When somebody disconnects, we receive the ID. Actually, we don't receive it, but we need the ID. And we can actually just send that message back to everybody, basically, by doing a remove this player from our client list. And then we tell everyone that somebody else has disconnected. We can remove him from the list quite simply by doing clients remove, and then we'll find the client itself using a predicate again. So find x.connection ID is equal to CNN ID. We remove him from the list, and then we're going to tell everybody that he has DC'd by saying send. The code we use is DC in caps, just like this. Then we put a pipe sign and we put the connection ID, so CNN ID, next to it. Send that on the reliable channel. We need to have that information, and we send it to everybody, so our all client list. Alright, let's actually put that right here, and everything should be done at this point. Okay, well, everything but the movement update. So that's going to be the next step. Let's go under build settings, build and run. We're building the server, and I'm also going to be building the client just afterward, so we can have multiple. So that's our server right here. Let's go back in build settings, let's swap these around, and that's going to be client. Okay, so we've got our server running right here. Gonna launch this, that's my client. Let's actually launch a second client and a third client, and why not a fourth one? Whoops. Okay, so we need to name these guys. I don't quite know how we're gonna name these. Let's go with really original name: Jerome, Dave, Chuck, and Miss Something. Okay, so we got Miss Something just running here. Dave is there as well. Jerome and Chuck. They don't have position update, which kind of sucks, but that's how it is at the moment. If we have a look through this mess, if say that Miss Something needs to disconnect for some reason, let's see if it disappears on all three computers. We wait for a timeout. Timeout has happened. She disappeared. Now there's only Dave, Jerome, and Chuck left. Let's kill Jerome. Why not? And he's left only with Dave and Chuck. And just like this, we have created something that works. That's multiplayer right there. Okay. Now, if we just like, we're gonna add one more feature to this. We're going to add the position update, which should be quite simple. But if you need to do anything else, if you need to actually start laying down your lobby, I just encourage you to do so. Just try as much as you can using this tech. Then you'll find out like some perfect flow for your game, because every single game is gonna have different flow. Like I said, if you're running a Blizzard game, they're not telling you everybody that's connected to the server right now. They're only telling you who you're interested in. So your friends, recent players, or a player you're rating that you can match with, that kind of stuff. When you're opening up a Diablo game, you don't know who's connected to the server. You just hit the matchmaking right off the get-go. And in our case, since we're jumping into like a small private match, could be like a MOBA game, then we need to know everybody else who's connected to that specific match. So let's jump right into that thing again. We are going to, on the server, we're going to add few fields at the top here for the position update. I'm going to go right about there, say private float last movement update and private float movement update rate. 0.1 sounds like something really laggy actually. Let's do 0.05. So every single 0.05 we're going to ask every player where they are. That might be a little bit too overkill. I'm not sure. We're going to try it out and see what happens after that. Okay. So in the update loop, we have our basic receive message, but down there in the same update loop, I'll be asking the player for the position. So ask player for their position. And in here, I'll be doing something like if time.time minus the last movement update, if that's bigger than movement update rate, does that make sense? So if it's 5 seconds, the last update was at 4, so 5 minus 4 is 1. If it's bigger than this, okay, that's gonna work. Then last movement update is equal to time.time, and we're going to ask the position. So send ask position, and I'm not going to split it. Actually, I don't need to. And we're gonna be sending this over to the unreliable channel because we don't actually need to know like 100% sure. If we miss a frame, it's not a big deal. So we're sending this over to the unreliable channel to everybody. Okay. Now at that point, we have a new message on this side. So case ask position, and we can create a function that just sends that position back. So private void on ask position. And I feel like we should actually we should be sending the position of everybody last frame. So ask position could be using some parameters. Actually, I think I'll be using some more parameters. Yep, let's quickly go back. So message string message is going to equal ask position, then we'll put a pipe sign. Or I'll call this one MSG because it's having conflict. It's also having conflict. I'll just call this M. And inside of M, after the ask position, I'll just be sending over the position of every other player that is currently connected with us. So to do this, I have to iterate through the server client array again. So we'll do for each server client sc in clients. Do we have a definition? We don't have a definition for the position, but I'll put it in here. Public vector3. I don't know if I should be storing this as a vector3, but we are going to try position, and we'll do, we are going to do the client ID first. So let's do connection ID, and then split that with a modulo sign, then sc.position.x toString, modulo sign again, sc position.y toString. And you know what, I'm not even going to send the position.z because we don't need it. It's a 2D game and we're not moving on the z panel, so only send the x and the y. Plus we're gonna save some space. That's also very cool. Once we're done with all this, we're going to open up the space for the other player in case there is one. So I'll do plus a pipe sign at the end. Once this for each loop is done, I'm going to actually cut this apart by saying m, or sorry, you only declare a string here. We'll do m plus equal. Then I'll do m is equal to m.trim. We're trimming the very last character, and we can send this message over. So it's going to be really interesting to see what kind of message we get. However, something we don't have right now is a value inside of this position right here. So we need to send this over from the client to the server. So when we ask the position, we also send the position of everybody else. That's cool. Back on this side, we're going to be using the whole array. So string data ask position is going to do on ask position, we send over the split data just like this. Now we don't care about what's inside of data at index 0. That is, that's ask position. But after that is where it gets interesting. So we'll do a for loops for int I is equal to 1 as long as I is smaller than data.length minus 1. Then we do I++. And we need to update everybody's position at this point. So we have the player list and we also have the data. So we'll create a vector3 position. And well, first we need to actually split the other string like we've done here. So string array d data split using the modulo sign. The very first parameter of d is going to be the connection ID. So we don't really need that here. The second one is going to be x, and the third one is going to be y. So I'll be putting that on a vector3.0 at first, and I'll say position.x is equal to float.parse, and I'll be parsing d at the index 1. Position.y is equal to float.parse d at the index 2. Now as for z, like I said, we're not sending the z over, so we're going to keep that in between x and y right here. And then once we have that position, that proper position vector, we need to apply it to the proper player. Now we do have a player array, so we'll be using players dot find. Oh, actually, players at the index d0 int dot parse, of course. That's a lot of parsing. I'm sorry about that. Dot position. Oh, we don't have a position right here. Okay, so dot avatar dot transform dot position is equal to position. Okay, that's a lot of work, but for every single player after the ask position, we create a vector based off what we receive as a message, and then we move that player over. Now this is to update everyone else. Finally, at the end, send our own position. And I just realized that using this, it's actually going to update your player as well, which is going to cause some glitches. So prevent the server from updating us. We'll do that by saying if client ID, or sorry, our client ID is equal to d at index 0, we break from this for loop. Int.parse, we simply break from this for loop. Or actually, you know what, I won't do a break. I'll simply take all of these lines, put them in the if statement, and reverse it around like this. Okay, once we're done updating everybody else, we need to actually send our own position, tell the server where we are. So we're going to say send. Our message is my position, something like that, why not? And we are going to include our vector x, or our position x, and our position y. So string m is equal to my position. Then we have to find our own player, so let me just create another vector real quick. My position is equal to players dot find, or sorry, our client dot avatar dot transform dot position, and it will do plus my position dot x to string modulo. We're almost done, guys. Modulo plus my position y to string, and that is actually it right here. we're going to send over our message M. Channel ID is unreliable. We don't need this to actually reach the server. That's my X, that's my Y. Cool. Last thing we need to do is parse this message from the other side, and we are going to be done. So, case my position on my position is going to be a function that contains the split data. Actually, it's not going to contain the split data. It's going to contain the position X and the position Y. So float.parse split data at index 1 and float.parse and actually split data at index 2. Do we have everything we need here? What is the crash? We don't have a break, is that it? Okay, now this function does not exist. Let's quickly create it. Private void on my position takes in the X and the Y, so float X, float Y. Oh, and also the connection ID. We need to send over the connection ID, so I'll put it right here to know which player has been updated, basically. Okay, now we take this information and we store it inside of the player definition, actually the server client definition. So clients.find, clients.find, we find the client where the connection ID is equal to the CNN ID we receive. Then we say dot position is equal to a new vector 3, X, Y, and 0. And we are finally down. I can't actually name my predicate X because I use it right here, so we'll name it Z. Why not? Oh, that's also very confusing. I'll just name it A. Or C for client. That makes a little bit more sense. And guys, I think we are done. Took a while. It's really complex, but I think we went through the whole thing. So just to celebrate a little bit, might be too early to celebrate, but I'll be creating both a client and a server build, and we'll be running a bunch of those. So that's my client right here. Let's move this over. Or you know what, I'll just run my server directly from the engine. So here it is, that's my server. It's sending ask position very often, as you can tell. It's not receiving any messages, and that's totally normal when we don't have anybody connected. So let's actually link Dave in here. We seem like we have some problems. We had one crash. Unknown character. I can't actually tell what this is from, but that's my position right here. And then modulo. Okay, I think it's trying to parse with this character in, but it's not doing it afterward. We'll go back and try to find out that problem really shortly. Now we have to launch another instance of this. Call this Michael, connect. And it does not seem like it's working properly. Let's see what's going on. So when we ask position, we have 380 and 390. I'm not quite sure where it says 380 and 390. I'm actually going to remove collapse so we can see what's going on down there. Okay. So we don't get any different messages, which is quite annoying to be honest, and on this side either. So let's actually go read our crashes. It pretty much always says that there is a unknown string modulo. So there has to be like a simple mistake on my end. And I think I nailed it right here. So when we're the client, we're sending our position using position X to string, and then we're putting a modulo sign, but instead we're going to be putting a comma sign, sorry, a pipe sign. the simple reason I'm doing this is since we're always like there's only one person, we're only sending the data for ourselves basically. We can put our X in the slot 1 and our Y in the slot 2. The way I was reading it did not really work. I was reading from an index that did not exist, so that was causing us to crash. Now right here, let me go quickly check my position. Now we're reading exactly from where it should be. So float.parse, we're parsing the X, and float.parse at index 2, we're parsing the Y. Quickly again, I will be booting this. I'll be building this as a client, and I'll be running it from the engine as well. Okay, I'm getting a little bit confused, sorry about that. Been recording for a while. So that's my server right here. That's Dave with a nice typo in it, and we'll be running another. Let's go look at the messages we get. So we get a bunch of ask position. We do not get the crash we had earlier, and then we get the position that is Dave's position. Is it? It says 38 and then minus something. So I feel like there should be something in between here. There should be something that splits this data. Or I might just be wrong because I'm confused, but we'll go find it out really soon. So that's Michael right here, that's Dave on this side. Position is not being updated, so there's something wrong, of course. Let's actually find out what is wrong. So we're like sending a bunch of ask position, but we're not receiving any message, so that is definitely something wrong. We used to receive messages, so receive from 1 and then we get a message, but I think we're just going too fast. This might be a big problem because they're not sending anymore, like we're not receiving any more messages. So let's close these two guys. Let's head back in the game and slow this down. Maybe we just overflowed everything. Movement update rate, let's put that on 0.5, like big granny speeds. And I'll be building the client. Actually, I'll be building the server this time, just to see if we have any crash on the client. Because in case we do have crash on the client, we can't see it since we're not running in the editor. Kinda sucks. So here is the server. That's client. That's Dave. And we did get a problem. So here it is. That's the problem we we're getting earlier. So the key given was not present in the dictionary. Let's go find out what is the key. Well, first they do ask position, and then they send us 380. Alright, so it turns out we're asking the position before the player is actually instantiated. So we're gonna say if we have not started yet, let's not try to update the position because we don't have a position at that point. So if it's not started, let's do a return. Now again, just going to make sure everything is clean. I'll start another build of the server. Yes, we would like to replace this, and then I'll start a build of the client as well. So that's my server. That is right here, my client. Or okay, I think I just missed my names, but basically that is the new server is right here, and the new client is right there. So this is Dave. Let's go find out if we have any crashes using the Unity engine. And this is Michael. So we do have again crashes on this side. Feels like nobody's being updated properly. And let's go find out what is the problem this time. So we did fix the first thing where we did not have the key in the dictionary, so that's fixed. Now we have a input string was not in the correct format, so we have to find out what is that problem right here. Okay, so it turns out that I found out what the problem was. It's something quite annoying, to be honest, and let me quickly show you the code. So basically what we do here is we iterate through every single one of the client, and then we create some kind of string that says, okay, so that's my connection ID, that's my string ID, that's my position X and position Y. And that works just fine in theory, but the problem is, once I was actually looking at what we received in parameter, me just quickly build a client right here. That's a server running in the background, and if we just run this code, this one updates just fine. However, if we have a look down here, that's not the ID. The first thing we get is not the ID. In fact, we don't even get the modulo sign. The position is minus 2.14 in X, and then in Y it's minus 0.16. However, like the 38 at the beginning doesn't make any sense, and that made me think, well, that's the int, that's a number basically. So what's going on? Why is this a number? Then you realize that, yeah, this is an int, this is a number, and what it did is it took that int, so in this case connection ID would be 1 for the first guy, and then it added this character. Because I didn't use the strings, I actually used character right here. It actually converted this into an int. So ampersand would be equal to 37, and connection ID would be 1, so we'd get 38. Something really important to do is we have to add the toString right here, and that is the only thing that was crashing our thing actually. So I'll go ahead once more for the last time, hopefully the final time. I will build a server, run it. Let me just quickly put the right thing here, and hopefully after this we can actually call success. So server is running. Now client is running as well, and we'll also run one instance inside of the engine itself. So let's connect the this guy first. This one's gonna be Dave, our favorite guy. He's moving just fine, and that one is Michael. Are they moving? They are moving. This is done. This is about time, but we're finally done. Now of course it looks like crap, and that is because you're only updating the movement every 0.5 seconds. Now multiplayer games such as Call of Duty or any shooters, what they do is called movement interpolation. In real, you're always going to have that chunky movement update. That's the data part. It's always going to be super chunky, but what those people do to make it look like it's instant, like the movement is instant, is they interpolate. So they're going to take the position you were at, your new position now, and on the next frame, since they don't have that data just yet, they don't have your new position data just yet, they're going to make you slide towards that direction. And that is pretty much what movement interpolation is. So this is also why in some games such as Call of Duty, even if you're shooting at the person, he might not be hit because that's not his real position. That's where the game guessed he would be at that very moment on your side. However, on the server, he might be 2 steps forward, he might be 3 steps ahead. It really depends on the movement update at that point. But you see it in other games where when people lag a lot, they start teleporting, but they still slide their way in a direction, and then they start teleporting in the other direction. That's because the server can't keep up. Now the better your server are, the faster you can do your update loop and receive and send that information back to everybody. So guys, this is actually where I'm going to be ending this stream. Hopefully you enjoyed it, hopefully you learned something, and if you didn't, well, that really sucks. But if you did, please leave a like on the stream video. I'll be posting that on YouTube. And yeah, so look out for more tutorial later on. I'll try to just make this structure a little bit more readable, make this structure a little bit more fun to use, and maybe create some kind of convention around it, and I'll post it later on the website. So guys, thank you so much for watching. Don't expect any deadline on that, by the way, because I still have a lot of research to do. But yeah, that has been this stream for the 30th of March. Thank you so much. I'll catch you guys later. Peace.